Hey everyone, this is your weekly episode of the Zephyr Podcast. I'm Benjamin, your co-host.
And Fabio, your other co-host. And we still don't have an intro music. Do you know who could make one for us?
Someone reasonably famous in the open source ecosystem created a new GitHub repo with an open source project for a guitar pedal. Like, what's that? I completely missed it.
Yeah, I didn't realize it was a thing, but apparently none other than Linus Torvalds started a guitar pedal project, and I checked it last night, and it's actually pretty cool.
It runs Zephyr? Tell me it runs Zephyr.
No, it doesn't run Zephyr yet, but this is the thing. He apparently wants to go for analog design, but the thing that he has on the repo right now is something with a board called the Daisy Seed, which is apparently a maker type board for audio processing, and it runs an STM32H750. It has 64 megabytes of RAM for sample, loop, stuff like that, a bunch of flash. It has an audio codec, obviously, and it does not run Zephyr. So maybe somebody should add support for that board. And yeah,
well, we should fully. I mean, from what I see, it should be pretty easy to create the board definition in Zephyr. Yeah, that's pretty interesting. I actually wonder, like, obviously we have support in Zephyr for a bunch of audio stuff. Like, have you played with it yourself?
Not really. I actually did buy some stuff a few years ago, but I never got around to it. But listen, there's certainly a decent level of support, right? With Nordic being so invested in the project and so invested in Bluetooth audio, I'm sure that thing can happen. But I haven't seen much from the community. But with this event, I'm sure that there will be more interest around it. So yeah, maybe something for the future.
Yeah, I was looking at the data sheet or like the specs for this particular Daisy Seed board. It looks like whatever audio codec they use, a TI PCM something. We have a driver for something reasonably similar, a bot number that seems close enough. So yeah, we might be able to get full support and get Linus to switch to Zephyr.
Imagine that.
That would be pretty cool. Well, yeah, I mean, apart from that, what have you been up to this week, Fabio? Have you been working on cool new features and stuff?
Yeah, no, none at all. It's been a bit of a troubleshooting week for me for various reasons. Well, the first one, which is not quite Zephyr related, is that I was helping out a local volunteer organization fixing up a couple of problems with their web server, which as it turns out, it's a PHP system
running on PHP is fine for
running on IIS on Windows Server.
Yeah, okay, you should have stopped at PHP.
That is out of my comfort zone. But anyway, so beside that, I've been troubleshooting an interesting issue with our project that took us a while. So this is something that I want to talk about because it's particularly nasty, and I suspect that a bunch of people in our audience will immediately recognize what the issue was because they bumped into it before, maybe, but I haven't, and it took us a long time to find it. So this was a very hard to reproduce bug that was causing a problem in one of our higher level driver. And it was caused, I'm going to jump straight to the conclusion, it was caused by the specific implementation that we have in Zephyr for min, the macro that gives you the minimum of two numbers. And the problem with that macro, as it turns out, is that the way it's written, it evaluates the argument 2 times, which doesn't sound like a big deal. But the problem is that if one of the arguments, the problem. So if you pass a constant, a literal number, it's not a problem. But you can pass a function, and if you do pass a function, the function gets evaluated twice. Now the problem is that if the value returned by the function changes, this can lead to interesting behavior. So in the specific case that happened to us, it seems like an interrupt was firing between the two evaluation, which was changing the return output of the function. So what we ended up, what resulted out of that is that we essentially ended up with a line of code that was calculating the minimum between 1 and 1, and the resulting output was 2, which ended up skipping an element in a queue, and the other result was funny, let's say, not very funny.
But so would you say, because I'm pretty sure, I mean, I didn't look, but I wouldn't be surprised if this macro, and I guess Max is impacted just the same, they probably have been in the Zephyr code base forever, right? And nobody hit that bug before. So I guess where I'm getting is like, is this really a bug on the way the macro is implemented, or could one say it's like your user code that should be more careful, knowing that it's a macro, being more sort of careful in passing constants and stuff?
You should definitely be aware of that if you have the mental clarity of catching it in the specific situation, right? And it's a very conscious decision. So I've been working on this the whole week because I don't want to be in the situation ever again. This took a very long time to troubleshoot. And it's a conscious decision. And we actually have a single call version of the macro in Zephyr, which is called z_min or z_max. And they actually are used, but very rarely. So what I'm trying to do now is I'm trying to put a bit of work, which turned into a lot of work, to try and actually swap the situation, make so that the min and max are safe, and we have an alternate macro for the non-safe variant. The problem being that you cannot use the single evaluation variant in a number of situations. For example, if what you're passing is a bit field, or if you're using it for build time analysis. So it's not that hard. Another thing worth mentioning is that Linux doesn't have a generic implementation for min and max, probably for the same reason.
And so as part of, apparently you're still in the process of fixing it. So did you find other places in Zephyr that basically are virtually impacted by the same bug that hit you guys?
Not really. It is very hard. Because I
guess what I was wondering if how much of that can be caught by. I mean, we ran things like Coverity and like other static analysis tools on our code base. I wonder if they would flag those kind of smells and patterns. And maybe they have in the past, and maybe that's why we don't have any problematic uses. It's
very tricky because the window for the race condition to happen in this case was only for assembly instruction. We actually ended up looking at the decompiled version of the function, but I'm sure that there are some bugs because of this in the code, right? It's not that hard to imagine that we have some subsystem level function that is designed to be, and this is the case in the case of it was a data structure that was designed to be lockless for performance reason. So we might as well have it. So anyway, this is some interesting work in progress.
Yeah, interesting. Like when you mentioned that story to me, I was like, hey, maybe this is something that our existing coding guidelines can also maybe help us sort of avoid. And it turns out that I think some of the coding guidelines we have would maybe sort of like help write code that's maybe slightly less efficient, but more safe in a way. Like there are rules that tend to say things like, hey, whenever you can, prefer inline functions to function like macros, because the macros, they can have side effects, like exactly what you described, stuff being evaluated more than once, and it's harder to spot in the context of macro extension.
And the Misra rule that you pointed out seems to be exactly for these kind of cases. So I think it's going to make sense. And it's my intention to try and use it to justify doing the change. But in this case, using the safe one would be more efficient as well. It's just less convenient from a coding perspective. So that was me. Well, anyway, how about yourself, Benjamin? What have you been fixing this week?
Well, I have not as many fires as you, I don't think. One that was funny or interesting is that every other month, I guess, we like one of the things I look after is the Zephyr documentation, and one thing that we provide to the users is a PDF of like 1,000+ pages of documentation. And sometimes it
7,000.
breaks, and I don't necessarily get an email telling me that it's not there. Don't necessarily get people telling me that it's broken. It's usually me who realizes. But yeah, it was broken for a few days. It's back.
Yeah, this seems to be a bit of a running story, at least within the release team. Every now and then the PDF documentation breaks and it gets unnoticed. And
I mean, I should probably put more like better like CI in place so that when it breaks, I'm notified, because it's not because people don't. Yeah. It's not because people don't say that it's a 404 for them or whatever, that they don't care and actually don't mind the PDF. Like it's nice typography, nice LaTeX formatting stuff. I like it.
There's a bit of an old school vibe.
That's fine. And yeah, and something else which I'm really excited about. So I was thinking for a bit that it was actually the pull request with the most heart emojis ever in the project. It turns out that it's close, but not. Like I think Rust got really like all the good plus ones and stuff a few months back, but this one is a close second. This is the DT Doctor stuff that we briefly discussed last week. I think really is right, like a tool that you can optionally enable when you build an app, and it starts a Zephyr app, and it starts telling you, hey, that node DTS underscore XYZ, like very obscure linker script errors or compiler errors. This tool, this doctor, is helping you make sense of that. So I'm super happy. Like it went in pretty quickly. People seem to really like it. I like it personally very much. Between last week and this week, actually, one thing that happens in the project is that every Saturday or every weekend we run over like 400,000 of unit tests and integration tests of like on the entire code base, and it's never fully green. Like there's always a few platforms, a few drivers that fail to compile, and a good half of those errors you see in the tests, they are exactly the kind of issues I was just describing. Device tree files that are effectively bogus, or configuration which is not in like the perfect shape, and you run those failed tests through the DT Doctor, and you save yourself, like even if you're like a really good Zephyr developer, you save yourself a few clicks and going through like 10 different files to make sense of like what's the root cause. So yeah, I think I fixed opened like half a dozen PRs fixing some of those failed tests, because it was just so easy to do. It feels like it could be almost automated. Like
yeah, congratulations on the feature, by the way. It went in extremely smoothly, which is
but there's not hardly any code. Like when you look at it, like it's at least for now. But like I was saying last week, I hope it will get smarter and start helping allow people to make sense of more complex macro failures and so on. Right now it's really the beginning, but I think it's like maybe 100 lines of Python code, and that's it. The rest is documentation. So
do you have a plan of more features you want to add to it, or let the community?
Yeah, I have some ideas, and without necessarily going into all the details, but I think all the information we need, it's always been there. We just need to like add some tooling to exploit it better. We have a bunch of, and that's the part that people typically struggle with, but there's a lot of macrobatics. That's kind of like the inside joke, but stuff that takes device tree files and through a bunch of Python scripts and a bunch of like really complex tool chain in a way, converts all that into a bunch of macros. And so, yeah, we have a script that takes care of that, making that script basically dump some kind of database of like all the symbols. It's all the device tree nodes. It's turned into effectively macros, and like keep all the traceability back and forth between the nodes and all the like potentially all the macros it's generated. Like, and once we have this kind of dump, this kind of database, I think we could we could diagnose like all the more complex macros that fail. Like when someone in the code tries to use device tree macros to navigate to the second parent of a given node, or to like the second child of the third parent, whatever, that macro that's like gigantic, we could like figure out where in the macro and where in the chain something is missing. A node is disabled, or a node doesn't have the proper configuration in place. So yeah, a long way to say that I think it can get smarter.
Cool. So is there anything, is there any other interesting stuff that you spotted emerged this week? Any cool boards or drivers?
So I don't know how people will feel about that, but I feel like name dropping some of the contributors that are doing amazing job. And it's like, I think it's our third episode, and Jonas, I think, came up one way or the other in every episode so far. I'm not even sure I met Jonas before. I'm not even sure Jonas has been around for that long, but we have someone by the name of Jonas contributing dozens of new shields, and apparently this week or last weekend, and now it's merged, lots of boards as well. So we have a new a handful of new RP 2040 Raspberry Pi Pico based boards. So I don't know. I think Fabio, you had like a quick look at some of them. They're all different form factors, different features, right?
Yeah, I had a look and I picked a few that I think are somewhat remarkable, just interesting in a way or another. So the first one is a Waveshare RP 2040 Matrix, and this is it's a small board. It almost looks like the Seed form factor. So very compact USB-C RP2040, and it has a bunch of LEDs. Anything that has so many LEDs, I think it deserves a mention. I'm not sure what's the use case, but you can probably do some funny display stuff with that one. So yeah, that's cool. Then
it's like basically an LED strip, but arranged in a square matrix.
Exactly. Yeah, I haven't actually looked in the details. Do you know if these are addressable or they are in actual GPIO style matrix? Because I've seen both in the tree.
It's like the good old WS2812 thingy, which I don't remember whether I double checked, but typically one thing that's interesting with those is that we have a way to turn, as long as you have an LED strip in your Zephyr, like in your device tree and on your board, if this LED strip happens to be arranged in a square, you can describe it as an actual display, and like
a frame buffer.
And like effectively use it with the display driver APIs in Zephyr. And sure, you only have maybe like an 8x8 or like I think even less, like 5x5 in this case, display, but it is a display. Like you can sort of like use LVGL or whatever to manipulate the things as pixel. But yeah, this one in particular, I don't remember. It's not even color LEDs. It's like just like white, I think. But still, yeah, like you said, form factor is really cool. Like super tiny. So
right. Yeah, then the other one you added was one of the Adafruit Metro board, which is an Arduino form factor board. So nothing extremely remarkable about that one, but it has an SD card, which is interesting because if you want to use it for doing data logging, it's there. And maybe worth mentioning that Zephyr has a disk subsystem. There are drivers for SD card, and there are actual file system, VFAT, little FS, probably more. So yeah, if you have any application where you need to store a ton of data, this could be a good one. Another thing I like about this one is that he put a proper debugging connection.
And we'll put the link to all those boards in the notes. You mentioned it's like Arduino form factor. It is very much Arduino Uno form factor to the point where there is actually like the DC barrel connector. I haven't seen that in years. Like it's interesting that you could still like power the thing with just a good old DC power supply.
Yeah, good. Yeah, good to see that there's a lot of variant, right? Like one may ask if we really need another Arduino variant, but there is some specialty about.
It's all about the shields as well, like being able to reuse all the shields out there.
Yeah, and talking about shield, this is a board that is definitely not gonna get a shield. So this is a Beetle RP2040, another RP2041, but this is something that I've never really seen. Did you ever see a board like that, Benjamin? We need to try and describe it.
Well, it's so you mentioned that the wave share thing is like close to the Bite Xiao from Seed. Like this one is even. It feels like it's probably more for wearable projects because the pads on the side. It feels like it's the kind of stuff that people would just you sew with like electric thread and like you make basically t-shirts and whatever with those kind of MCUs. Sometimes it feels like that maybe that's what it is.
Yeah, I think that that's the case, and that is something that I haven't seen for a while. So I'm wondering if it's either that or so that you can connect the banana clip on the pin. But yeah, it's very small, very big pads. So yeah, something different really. So
and it's like $7. I was just looking at it, $7. That's
these are very cheap.
Yeah, that's really cool. And I guess another board that caught my eye, maybe the PR will be merged by the time we go live. I think it's mostly ready to go. Eve, I should say, is at it again. There's actually a really good talk from her at the Zephyr Developer Summit a few weeks back, where she talked about all things displays in Zephyr. And Eve is an electronics engineer, basically by training and by that's her day job, and she likes to hack physical devices. And she was telling me she found a pretty nice mechanical keyboard in the street, like in a trash can, basically. So she was like, she took it home and then started to reverse engineer the thing. To the point where, she was able to figure out that I think it's an ST, right? An STMCU.
It's an F4.
Right. And a bunch of like LEDs, I guess, for the backlight of the, maybe for the backlight of the keys and stuff like that. But effectively, either it's already the case or it will be in a few days. We will have a board definition upstream for this particular keyboard because like there is a debug port available. And I mean, people can write and deploy an alternative firmware, which is really, really cool. And I mean, Fabio, I will probably have tons of questions for you because like one thing she had to go through beyond just basic enablement of like figuring out what the SoC was and what LED the SoC was connected to, buttons, whatever. There was the whole like the actual keyboard stuff and like keyboard matrix, right? I think that's what you call them.
Exactly.
So there's like a lot that went into that, and this is your subsystem, right? To some extent, the keyboard matrix driver.
This is it's quite satisfying to see some people using it, to be honest, at this point. So this is driver where I poured a lot of work into it, and I'm actually using it on my own keyboard. And we use it at work, obviously. This is something I did as part of my job. But for our stuff, we use chip with a dedicated keyboard matrix controller. The GPIO one is something that I wrote partly for using it myself and partially for testing. And in this case, so the TV is doing it. So this is a proper name brand Steel Series keyboard. And I saw that Eve implemented the GPIO keyboard controller, and I presume it's working correctly. And there's actually a lot of interesting details in the driver for this particular device for the keyboard matrix. So maybe in another episode we'll go into the
like I said, like I said, I will have tons of questions for you because basically you have those keyboards with like 100+ keys, and yet, I mean, most MCUs probably don't have 100+ GPIOs. So there's tons of tricks, which that's really cool. It was it was really a nice find, right? Because I was actually looking at it's like a 200 euros keyboard.
I never find this stuff in the track. Like, I want to know where she lives.
Well, that's really so cool. What else? I think, I mean, every week, even before we started to do those podcasts, I would typically spend some time looking at also the new drivers. It's usually a good indicator of like what the community is up to. I think one that's worth sort of talking about is there's a new driver for something that's effectively a so-called multi-function device, right, in Zephyr. A chip. So I mean, tell us more about it, and we can also talk to what an MFD is in the first place.
Yeah, so this caught my eyes because I have actually no idea what you're doing with this, because this is for a Motorola.
What is it? What's the name of the part?
It's a Motorola MC14 6818, which is a combined RTC and CMOS chip. And it's the one that apparently, we did some research on this, it's the one that apparently was used in the original IBM PC-AT. And it's the one that has eventually been implemented in the Dallas Semiconductor DS1287 and 12887, which, if you are in any sort of retro computing vibe, is that big rectangular RTC chip with integrated battery that failed on all very old computer. Somebody from Intel added support on Zephyr for that. And I don't know what they're up to. I opened the datasheet and it's dated 1988. So I'm not so sure what the story is. We need to ask.
Right. And so, so the driver is effectively a driver for the RTC bits, the counter, and BB RAM as well, apparently.
Yeah. So this is the multifunction part. So the idea of gonna have a driver that perform multiple functions, but you want to share some code, which typically would be the helper for write register and read register on the I2C bus. So in this case, the two functions are the RTC and the BB RAM. And the BB RAM is just a fancy word for a RAM with a battery. And this is what you would clear on your old computer when you push the clear CMOS jumper.
Mm-hmm. Yeah, and you want to have like shared code and also like mutual exclusion. Like whenever you use the RTC APIs, you don't want the other driver to try and do stuff at the same time.
I mean, if you're on the I2C bus, it's probably not super important. But if you have any locking you want between accessing the peripheral, between the various functionalities, between the subsystem, this is it. So anyway, if you want to take your ultra modern Cortex M7 and connect it to a 1988 RTC chip, there you go. You have a driver.
Yeah, or because like again to the MFD multifunction device thingy, what I usually tend to tell people is that, I mean, we don't have that many of them, but the ones that come these days, like this one just landed, they are like really good examples of how you should be doing multifunction device. So like, even if you're not interested in that chip in particular, this looking at how the driver or drivers are implemented is a good way to understand better how MFD works and potentially use it for your next projects and stuff. So Yeah, and I guess something else, and we were discussing before going live how many, like more and more, and many, a lot of silicon vendors are adding more and more drivers for their like built-in SOC peripherals, right? Like that chip we just talked about is like an external IC, but like every week, the vast majority of the drivers that make it into the Zephyr tree are the likes of Renesas and Espressif, NXP, Nordic, you name it, enabling new peripherals. And one that's I think really interesting is Renesas added support for their so-called CEU on the Renesas RA SOC series, and CEU stands for Capture Engine Unit, as in that's their video capture thing. So this is now live in Zephyr. That's as probably some of you noticed, video is kind of a hot topic these days for Zephyr. It's been for the last 6-9 months or so. We have like the USB video class available as well. So I guess now technically you can build a USB, a Zephyr powered USB webcam on Renesas hardware. So that's cool.
It's great to see. I've been meaning to experiment with the video stuff myself for a while. Maybe doing something simple like a motion JPEG Ethernet camera, something like that. You know, the kind of device that you want to be able to do on yourself, not exactly buy it for whatever reason. And yeah, this may be an interesting platform.
Will you be adding AI to it if you ever get around to do it?
No.
I would
I know you would.
As an excuse to play with image recognition and so on. It's another topic. And something else. Espressif is also like pretty good at sort of like catching up and adding all the peripherals that might not yet be supported. And I think as of this week, basically we have finally USB device support for all things ESP32, which is kind of a big deal because Espressif boards are really popular in the for like Zephyr users. And even if you look at like Google search and like how people end up on the Zephyr documentation and whatnot, oftentimes it's people a good chunk of the audience is like, hey, I want to run Zephyr on my ESP32 dev kit, either from Espressif or from Seed Studio or wherever. And so now, all those dozens of samples we have to do USB mass storage and USB video camera and whatnot, I guess they work on Espressif.
They are widely popular, and I'm a bit surprised that they didn't have any USB support until now. How is that possible?
Yeah, same. I was surprised too. And looking at the pull request, I mean, it's not even clear like how much work it required. I guess a bunch of work went into their own how to enable the stuff. But that's really, really cool. Maybe in another episode you will tell us about your ESP32 based Zephyr CI monitoring tool.
The CI traffic light, and the immense pain that it caused to make it work at ZDS. Oh yeah, that's it's one for the next episode. Hey, you know what I've seen in the list of commit that I was not expecting this week?
Tell me.
A PIC 32. This is
wait, what? Like those are like really, really small, really constrained, are they not?
Well, you're thinking about the
PIC 16.
PIC 8, the PIC 16. But this is interesting because there's a bit of history behind the PIC 32, right? The original one came out in a time when all of the vendors were going to Cortex M0, and M3, if I remember. And at the time, Microchip did a bit of a gamble, moving to MIPS instead with their own PIC 32. And I haven't really heard from them in a very long time. And all of a sudden they come back with this PIC 32C family, which are spotting Cortex M0. So I guess welcome back.
Yeah. Actually, it's just as a side note, that kind of, and I could have said the same for the MC whatever RTC chip that you were mentioning
Yeah,
before. There's an interesting challenge, I think, in the Linux and Zephyr community, which is those vendors that keep acquiring one another. That makes for interesting vendor prefixes in our, like our compatibles in the device tree, etc. Like, I mean, the MC, like the RTC chip, like effectively these days, I guess it's meant to be NXP, but it used to be Dallas and used to be whatever. Like, and so what should the prefix, like, how do you call that in Zephyr? I guess it's never going to be perfect. Like it's stuck to whatever. Yeah, when the pod comes out, it's with vendor X and then it stays with it no matter what.
right. Yeah, it's odd.
Yeah. So yeah, I mean, I think that's the kind of stuff that was worth looking at for this week. Do you have anything planned for the weekend and for next week? Are you still going to work on your min thing?
Yeah, I'm probably gonna fix min and generic min for the rest of the day. Hopefully not the whole week, but yeah, it may that pull request may appear at the architecture review. We'll see about that. What else is going on, Benjamin? Do we have
Yeah,
some
well, I guess
announcement to make?
as we stop recording, like in the next hours, hopefully, or by the time we go live, our annual Zephyr Developer Survey will likely be out. And so I will be putting the links in the show notes, or if you don't find them, then it'll be earlier next week. But that's yeah, I really hope to have many of you taking the survey. One thing that we hear every year, and I mean even beyond just the survey, people are always like, "Hey, device tree, why are you having us use device tree? This is hard, and all the macros and stuff." Well, we spoke about GT Doctor just before. Maybe by the time, I mean, yeah, the survey is just coming out, but maybe some of you will be like, "Hey, okay, device tree, this is getting better. We have better tools." So I hope to see a bit of that. And
Yeah,
and
we
I'm heading to
really
Amsterdam.
read the feedback for the survey. So like if you have 10 minutes to spare, it's really not a long one, and yeah, please do it.
Yeah, tell us what works, tell us what doesn't, and like don't be shy. And as always with surveys, we ask you to tick a few boxes, but it's not only about that. Like use all the text fields that we put there for free form comments. That's where you want to share what you have in your mind. Yeah, and next week, personally, I will be back in Amsterdam, I guess, after ZDS, this time for the Things conference, which it looks like it's going to be really big this year. So yeah, I will probably have a few things to say in our next episode. But meanwhile, I should probably finish my slides before they start getting mad at me and send my slides for the I have a small segment where I will be updating the attendees on some of the cool stuff that's happened in the Zephyr community over the past 10 years, basically, because like we are getting really close to turn 10 years old. So that's going to be sort of like my angle. Yeah. With that, I guess this is for your third, Fabio.
Third, okay.
Third episode of the Zephyr
all
Podcast.
right.
Join us. Yeah, don't forget to subscribe. I know that many of you watch on YouTube. That's great. Just keep on doing it. It's actually also easy to share your thoughts and comments. But we're on iTunes, Spotify, Deezer, and probably a few other platforms. So please do subscribe there, like, share, star, whatever. And we will be creating a Discord channel as well. So that's also one way to come and join us. Ask questions. Like I'm pretty sure like now that this is hopefully growing and we will have more of an audience. If any of you want to see something, want to see some questions answered on the show or some topics that you would like to see covered, just let us know. And with that, we will be back in a week. And yeah, have a great weekend, everyone.
Bye.